SN1 reaction. What is the full form of SN1? Substitution for S. N stands for nucleophilic and 1 means it is a unimolecular reaction. So substitution nucleophilic unimolecular reaction means SN1. Alright. So what happens actually in SN1? In a protic solvent SN1 is favored and in a aprotic solvent SN2 is favored. What are protic solvents? Protic solvents are solvents which produce H plus. So examples of a protic solvent is water, ethanol, carboxylic acids. They give out H plus. So these are protic solvents. Whereas aprotic solvents, we have examples of DMF, DMSO, because they do not give out H plus, they are aprotic, and water, ethanol, carboxylic acid, they give out H plus, so they are protic solvents. Protic solvents favor SN1, aprotic solvents favor SN2. What is the mechanism of SN1? I'll show you what the mechanism of SN1 is. In SN1, the first step is basically in a solvolysis. I am talking about SN1 reaction. So first step is solvolysis. What does solvolysis means? Solvolysis means breaking down of alkyl halide by the solvent. See, we have something like this, and let's say it is a iodoalkene. So what happens? Iodine will have a partial negative and carbon will have partial positive. So water molecules, let's say this reaction is happening in an aqueous medium. So water will surround this carbon as well as I minus depending on what kind of charge it is. So this will be surrounded by hydrogen and partial H plus, and this has partial negative. So H plus end surrounds halogen, whereas oxygen will surround carbon, partial negative, partial negative, partial negative. So what happens is the attraction between O of water and carbon plus increases and attraction between carbon and iodine decreases. Similarly, attraction between I and hydrogen of water increases and attraction between carbon and iodine decreases. So gradually what happens is this bond is broken. This bond is broken. So what do you get? You get carbocation. You get a carbocation as well as halide ion, which will of course be hydrated. Alright. Now in step 2, attack of nucleophile occurs. So attack of nucleophile occurs on a carbocation which is in trigonal planar shape. So nucleophile can attack from the front as well as from the back side. Since the attack can occur from both the sides, we get a racemic mixture where nucleophile is present on the front side as well as the back side. So you get a product something like this, where we have nucleophile attacked at the front as well as at the back. So you get a racemic mixture. If I expect these are different alkyl groups. If it is a chiral carbon, so this mixture will be known as racemic mixture. If all these alkyl groups are, let's say this is R1, this is R2, this is R3, and this is again R1, R2, R3. So we get a racemic mixture in SN1 and Walden inversion product in SN2. So that is what the mechanism of SN1 is. Now, how do you figure out whether a particular reactant will show SN1 or SN2? I'll give you a trick for that. Just remember, if it is a 3 degree alkyl halide, you have SN1. If it is 1 degree alkyl halide, you will have SN2. In 2 degree alkyl halide, we have possibility of both. SN1 can occur as well as SN2. SN2 can occur. So how you will find out whether SN1 is happening or SN2? Check out whether protic solvent is there, protic solvent, protic solvent or aprotic solvent. If aprotic solvent is there, SN2, protic solvent will show SN1. But in 1 degree, always SN2, 3 degree, always SN1. This is how you figure out which kind of mechanism will be happening. But in benzyl and allyl halides, only SN1 occurs. The reason is they have a resonance stabilized carbocation. In SN1, carbocation is formed, so more is the stability of carbocation, more will be the effectiveness of SN1. So in allyl and benzyl halides, SN1 is more prominent than SN2. We have few differences between SN1 and SN2, which we have already discussed, but they have been summarized over here, such as SN2 reaction is a bimolecular reaction, SN1 is a unimolecular reaction, SN2 you will have transition state, no carbocation, SN1 you will have transition state as well as carbocation formation. In SN2 Walden inversion occurs, in SN1 racemization occurs. In SN2 you will have one step reaction, but in SN1 multi-step reaction. In SN2 aprotic solvent will favor SN2, whereas in SN1 you will have protic solvent that increases the reactivity. So these are few differences between SN1 and SN2. Alright, so I hope we have discussed everything over here. Thank you so much.